Okay, Lamai, we talked about this part, composition of a mixture. So, composition of a mixture as a mass fraction we talked. තොට අපි නිකම්ම mass එක තමයි consider කරන්නේ. Mass of අදාළ relevant compound over mass of that relevant compound plus the other compounds. හරියට දැන් අපි solute එකක් solvent එක dissolve වෙලා තියෙද්දි solution එක ගුණොත් අපි salt වල mass එක මෙතනට දානවා. ඒ salt වල mass එක plus water වල mass එක මෙතනට දානවා. ඊට පස්සේ composition of a mixture as a volume fraction. එතකොට ගන්න volume එක. එතකොට salt වල volume එක අපි ගන්නවා cubic centimeter වලින්. ඊට පස්සේ total mixture එකේ volume එක ගන්නවා. Now we are going to talk about another thing which we call as mole fraction. This is an important one, but it is also an easy one as before. The mole fraction of each component of a mixture containing only two components A and B can be expressed as follows. So mole fraction of A, you have to write here amount of moles of A, amount of moles of A plus amount of moles of B. Then mole fraction of B, amount of moles of B, amount of moles of B, A plus amount of moles of B. That means total number of moles and the amount of that relevant compound which we consider. Thus, the mole fraction of a component of a mixture is the ratio of the amount of moles of that component to the total amount of moles of all the components in the mixture. Worked example. What is the mole fraction of sodium hydroxide in a solution made by dissolving 40 gram of sodium hydroxide in 180 gram of water? Okay. Molar mass of water. Here the molar mass of water wala. H2O. It's H2O. So for H it is 1 and there are 2 H, so we have to multiply 1 from 2. Then you get 2 plus 16 for oxygen. 16 plus 2 is 18 gram per mole. That is the molar mass of H2O. So they have mentioned that how many sodium hydroxide moles are used there. That's it. 180 gram of water. 180 gram of water. So what you are going to do here? 180 divide from 18 gram per mole. Okay. 180 divide from 18 gram per mole. Because this is a molar mass and this is a mass. So this G cut into this G. Then this per mole come upward, then it becomes just mole. Per mole කියලා MOL minus 1 යට තියෙන්නේ. එතකොට ඉරෙන් උඩට එනකොට නිකම්ම MOL වෙනවා. ඊට පස්සේ 180 18 වලින් divide කරාම 1 for 18 18 වලට 18 ඒවා 1යි. මෙතන 18 වලට 18 ඒවා 1යි and මෙතන 0. එතකොට 10 mole තමයි එන්නේ answer එක. Okay. Now you have find out the number of water moles. So here what they are asking is mole fraction of sodium hydroxide. No? So here if it is sodium hydroxide, you have to write the number of moles of sodium hydroxide. You already have found the number of moles of water here. Okay, water is 10, but we have still to find out number of moles of sodium hydroxide. Now we are going to find out molar mass of sodium hydroxide. For sodium it's 23, for oxygen it's 16, and for hydrogen it's 1. So 23 plus 16 plus 1, we are getting the answer like 40 gram per mole. 40 gram per mole, okay. So amount of moles of sodium hydroxide in the solution is 40 gram over 40 gram per mole. 40 gram over 40 gram per mole. So 40 to 40 ගියාම 1 එනවා. gram to gram කැපෙනවා. per mole එක උඩට ආපෙන් පස්සේ මේක per mole එක නිකම්ම mol වෙනවා. ඉතින් උඩට ආවම -1 එක නැතු වෙනවා. එතකොට 40 to 40 කැපිලා 1 තමයි අපිට එන්නේ. එතකොට number of moles of sodium hydroxide as the for the given mass is 1. එතකොට මෙතන 10, මෙතන 1. How it could become? Here it's 1. Here it's mole fraction of sodium hydroxide. It's 1. And here also it's 1. So here 10. So 1 over 1 plus 10 means 11. 1 over 11 with 10. Here mole fraction of sodium hydroxide in the solution. Amount of moles of sodium hydroxide. It's 1. Amount of moles of water. It is found here. It is 10. Then again amounts of moles of sodium hydroxide as 1. So 1 over 11. Okay. Similarly, the mole fraction of water in the above solution can be calculated. It doesn't ask in this question, but you could find it. Then it becomes here 10. Amounts of moles of water 10. Again the total amounts of moles of all the solution is 11. 10 plus 1. Then 11. 10 over 11. 1 over 11. 10 over 11. Sum of mole fractions. Now we are going to find out the sum of mole fractions. Okay. Mole fraction of water is 10 over 11. Mole fraction of sodium hydroxide is here 1 over 11. So 10 over 11 plus 1 over 11 means 11 over 11. Then 10 plus 1, 11. Then what is the answer? 1. So the sum of molar fraction is what? 1. This is a constant, okay? The sum of mole fraction of all the components in a mixture is 1. The sum of mass fraction or volume fraction of all the components in a mixture is equal to 1. So මේ ඔක්කොම sum of mole fraction, sum of mass fraction, sum of volume fraction. මොකද මේවා fraction නේ. The fractions ඔක්කොම එකතු කරාම it should be equal to 1. Let's use another color. Sum of mole fraction. Sum of mole fraction, mass fraction, or volume fraction. These all are equal to 1. There are no units for the mass fractions, volume fractions or mole fractions of a mixture. Units capillary fraction wise here. Amount of moles and method of MOL in method of palha MOL to MOL capena. Here also where volume fraction may volumes in here. So method cubic centimeter value cubic centimeter hari cubic meter තිබෙනවා cubic meter වලට cubic meter hari capillary යනවා. එතන මේ ඉතුරු වෙන්නේ නැහැ units. මෙතනත් gram වලට gram. මේ ඇවිල්ලා compression mass fraction එක. gram to gram capillary යනවා. එතන මේ කිසිම එකකට units නැහැ. No units. Units for the mass fraction, volume fraction or mole fraction of a mixture. The composition of a mixture expressed as a fraction can also be expressed as a percentage or as parts per million ppm. එතකොට මේක percentage එකක් විදිහට පෙන්වන්නත් පුළුවන්. Like that. Percentage එකක් විදිහට පෙන්වනවා නම් දැන් අපි හිතමු මෙතන 11 over 1 තියෙනවා කියලා. ඒතර percentage එකක් විදිහට පෙන්වනවා නම් ඒක multiply කරනවා 100%. මෙතනත් එහෙමයි. 10 over 11 කියන එක multiply කරනවා 100%. ඒකට percentage එකක් විදිහට එනවා. හරිද? එතන මේ හැම තැනදීම multiply කරොත් 100% වලින් ඒක percentage එකක් විදිහට එනවා. මේ also. ඒතර percentage එකක් විදිහට ගන්න අදාළ fraction එක you have to multiply from 100%. Okay. Then composition as parts per million. එතකොට parts per million වලින් ගන්න නම් million වලට parts කීයද කියලා you have to multiply that fraction from million. Okay. Parts per million. Normally we tell it as ppm. Generally we consider it ppm, short form, parts per million. Okay. Worked example: 20 gram of dolomite contains 12 gram of magnesium carbonate. 20 gram of dolomite contains 12 gram of magnesium. So dolomite and magnesium carbonate. Calculate the mass fraction. So 20 gram of dolomite කියන්නේ total එක. ඒක ඇතුලේ තියෙනවලු 12 gram of magnesium carbonate. Calculate the mass fraction. හරිම ලේසි mass fraction එක අහලා තියෙන්නේ. Of magnesium carbonate and express it as a mass percentage. එතකොට mass fraction එක බලනකොට අපි කොහොමද ඉගෙන ගත්තේ? 12 gram comes here. 12 gram එක included නේ මේ 20 gram වල. මේක ඇතුළේනේ 12 gram තියෙනවා කියන්නේ. ඒතර පළවෙනි 20 gram තියෙනවා. So gram to gram කැපිලා ගිහිල්ලා we get this answer. So now they are asking it as also a percentage wise. So you have to write it as a mass percentage. It's like here. You have to multiply it from 100, then you get 60%. That is a method of getting percentage. Next one is expressing composition of a mixture in terms of mass over volume. This expresses the mass of a solute contained in a unit volume of a mixture. 1 dm 1 cubic decimeter of G1 solution. G1 solution එක 1 decimeter එකක 5 gram of sodium chloride තියෙනවා. The composition of solute එක මේ mass volume එකට ගත්තාම sodium chloride mass එක 5 gram. එතකොට total මේ volume එක මෙතන total volume එකම 1 දීලා තියෙනවා. මෙතන 2 වගේ දීපොත් මේක divide වෙනවා. හැබැයි මෙයාලා 1 නේ දීලා තියෙන්නේ. ඒතර අපිට ලේසි 1 වලින් divide වෙන දෙයක් නැහැ. ඒතර 5මයි gram උඩ dm per square per cubic meter. Decimeter per cubic meter. 5 gram dm minus 3 විදිහට එනවා. මෙතන 3 එක උඩට එද්දි minus 3 වෙනවා. මේක තමයි answer එක වෙන්නේ. Okay. මෙතන 2 වගේ තිබ්බනම් අතන 5 වගේ තිබ්බනම් ඒව divide වෙලා answer එක එන්නේ. Expressing composition of a mixture in terms of amount of moles over volume. දැන් මෙතන ගත්තේ gram over volume නේ. ඒ වගේම number of moles over volume කියලාත් ගන්න පුළුවන්. This is used to express the composition of a homogeneous mixture. ගොඩක් වෙලාවට solution එකක composition එක කියන්නේ මේ විදිහට. Mole is the international unit for the amount of matter. Here the composition is given in terms of amount of moles of solute contained in a unit volume of a solution. මෙතන තිබ්බේ mass of a solute contained in a unit volume නේ. Of a unit volume of a mixture නේ. Unit volume කියන තැනින් තියෙනවා. එතකොට මෙතන තියෙන්නේ moles of a solute contained in the unit volume of a solution. The composition expressed in this way is called as concentration. We have a separate term for this uh, method of expressing composition, it is called as concentration. In chemistry, very often concentration of a solution is expressed in terms of amount of moles. Okay, in chemistry, very often concentration of a solution is expressed in terms of the amount of moles of a solute contained in a cubic decimeter of a solution. Worked example: 2 cubic decimeter of a solution contain 4 moles of sodium hydroxide. 2. You have to divide this 4 from this 2. But the so find the sodium hydroxide concentration. So you have to find out the units. Okay. So sodium amount of moles of sodium hydroxide in 2 cubic decimeter of the solution is 4. So you have to find out amount of moles of sodium hydroxide in 1 cubic decimeter of solution. That is a concentration. So you have to divide this 4 mole from 2 dm3. So මේකෙන් අරන් තියෙන්නේ අපි 2 cubic decimeter වල 4 moles තියෙනවා නම් 1 cubic decimeter වල කොච්චරක් තියෙනවද කියලා හොයන්න. 1 ඉතින් මේක divide කරත් එකයි 1 වලින් multiply කරත් එකයි. divide කරාම ඉතින් 2 වල 4 තියෙනවා නම් 1 වල එන්නේ 2 mole. 2 mole per cubic decimeter කියලා තමයි එන්නේ. 2 mole මෙතන මේ add වෙන දෙයක් නැහැ. ඒතර concentration එක විදිහට අපිට answer එක එනවා. මේ වැරදිලා mistake එකකින් මෙතන space එකක් ඇවිල්ලා තියෙනවා. මෙතන space එකක් නැහැ. හරිද? 2 mole per 1 cubic decimeter. එතකොට මේ cubic decimeter part එකට ආම 2 mole per cubic decimeter එන්නේ. Okay. What is the mass of glucose required to prepare 1 dm3 of 1 mol dm3 glucose solution? There's something you have to learn and I'm going to discuss it later. Then with that I can discuss, with this question I can go to this preparation of standard solution and learn more about them. Okay. Then I think after one we could come to the separation of compounds in mixtures lesson. Yeah. So I'm going to stop here. Thank you.